But now, when I'd like to come back again to our subject, or our today's subject of abstract, concrete, because if I summarize your view, but maybe it's not your view, you will tell me. It's just like, you seem to me like really like, maybe today more than the other times that we were talking, of a Platonician. Because for you, it's like if the truth and an infinity, even of the mathematics of that, is just, it's like if mathematics is the truth, and the empirical world is the imperfect view, like, an imperfect view that we have that is somehow a little bit twisted, so that we don't see the world, we don't see totally the truth. And so when we do mathematics, it's like if we had a purified view. So for you, the empirical world is something that is, we'll say, a degradation of the purity of the world of mathematics, and not the other way around, because some people think that it is the other way around. So the mathematics were just born out of the measurement of the world. And so what is actually perfect but is the world, the empirical world, and mathematics simplify this world, and so is in fact empirical, but just a simplified view of empiricism. You don't have this view. Your view is not, the pure world is mathematics, and it's actually the world that we face that is a degradation.
It's more my view is more complicated than that. You see, the higher order, the Platonic world of ideas is not well defined. It's contradictory when you go to enormously big sets or enormously high infinities. So to avoid that, I like to stop with the whole numbers. If you say that the infinity you really believe exists is 0, 1, 2, 3, 4, 5 forever, that basically keeps you down at the level of discreteness, and that's safer. And there you can talk about algorithms. And this is a relatively down-to-earth version of the Platonic world of ideas. Because you see, the problem with the Platonic world of ideas is it's in statu nascendi. Given any collection of infinities, given any infinities that you can imagine, you can always put them into a bigger set and take the subset of all that, the set of all subsets of that, and then this gives you an even bigger infinity. So that's a contradiction. The set of everything, you cannot conceive of the sequence of infinities as closed in any sense. It's always under construction. If you think of it as a closed entity, then you get a contradiction. That's called naive set theory. Naive cantorial set theory is contradictory. So then it's not clear where to make the cut. So the Platonic world of mathematical ideas is dangerous. It's not clear how far you want to go. And I like to stay as safe as I can, but without infinity, you don't have pure mathematics. So I like to stay with algorithms and discreteness, 0, 1, 2, 3, 4, 5. That is a safe infinity.
That's the reason why you like to think that the world is made of discrete particles instead of waves, because it's not safe enough for you when we are...
Yeah, as you go to higher infinities. So that's a problem, that maybe it's not well known. The Platonic world of mathematical ideas is in statu nascendi. Another way to put it, it's contradictory to think of it as a completed whole. So
you like infinity, but you don't like infinite infinities.
Yeah, mathematicians don't like,
because waves,
they want to avoid contradictions.
Are infinite infinities, but infinite number. So infinite discrete particles that we could call, let's imagine that those numbers are every time refer to a particle, 1, 2, 3, 4, 5. They have the advantage to be finite particles, because in fact they have borders in themselves, and so you count them to infinity. So it's an infinity that is not infinite.
It's a down-to-earth infinity.
Exactly.
It's a relatively concrete infinity.
Oh, it's concrete.
It's not a terribly dangerous infinity.
I like the word dangerous. When you use the word dangerous, it's dangerous because you don't know where you're going to end. Actually, that's the problem.
And you
with
even
it.
get into contradictions, and in pure math, a contradiction is rather scary. It can be fertile. It can suggest new ideas, but
but do you think?
And it's also scary in the physical world, because if you go down to very short distances and very high energies, and space and time seems to sort of disintegrate with virtual particle creation and annihilation. It just crumbles in a heap.
But you mean it's dangerous, like, you know, when they say that the Greeks said that you can't look at the gorgon in the eyes, so it doesn't. I mean, it doesn't matter if you don't look at it, if it is the truth.
Yeah,
so
well, you can't look at the electron in the eye, because if an electron actually is a singularity, it has an infinite amount of energy. There's this problem with measuring. I think it's certainly true with Maxwell, classical electrodynamics. I'm told that Feynman says it's also true in quantum field theory. That's not an area that I understand. But wherever you look, there are dangerous questions that physicists don't ask or mathematicians don't ask, because...
So they are scared to ask?
Yeah, because you get contradictions, and the contradictions in the world of physics are infinite. Infinities, infinite energy or something that's impossible.
But don't you think that trying to think from contradictions is a great way to become humble and at the same time closer to truth?
Well, yeah, it's
instead of feeling safe and saying
being humble is not necessarily good. If there's a contradiction, if an infinity comes out in a physics calculation, I think what it's telling us is that our understanding of physics is limited or wrong, because physicists say there can't be an infinity, which means we don't actually understand what the electron is yet.
Yeah, of course.
Or that our theories don't work at that scale if you get too close to the electron.
So that's good to be humble, to realize that.
But you shouldn't be humble. You should realize we don't know, and we should try to figure out.
To realize you don't know, you don't think it's a little bit be humble?
Yeah, that's humble, okay, but it means we need to know more.
Of course, I usually
you need to understand that
I usually say that it's the difference between modesty and humility. For me, it's like modesty goes with some kind of pretension, while humility, like being really humble, is feeling humbled by the ambition that we have, like a great ambition. So I always say, I'm humble because I'm ambitious, but I'm not pretentious, and I don't want to be modest. You know.
Yeah, one has to realize.
Do you agree with that?
Our current physical theories are not the last word, and one of the.
That's for sure.
And it's for several reasons. There are experimental, there are observational things that we don't understand, like the dark matter, for example, is a well-known conundrum. But there are also internal contradictions. Like when you look at the electron, if it's a singularity, you get into one problem. If it's a little sphere, you get into other problems, Poincaré stresses and everything.
Yeah, exactly.
So physicists don't ask that question, but one ought to. And the same thing happens in pure math. The naive set theory is contradictory. So the question is, where do you chop it off? So that means also that it's not just physical reality that we don't understand, but mathematical reality also can get you into trouble. In math, it's a contradiction. In physics, it's an infinity coming out as a result of a calculation.
I like your vocabulary today, like get into trouble, dangers. It's interesting.
Danger, big sign, danger. You know, like you're in the mountains and it says, stop, there are crevasses. There are crevasses, you know.
Yeah, don't go there.
Yeah, don't go there unless you're prepared to to deal with crevasses, right?
Yeah.
You need ropes. You need at least two people.
Don't you think? I think for me, the definition of a philosopher is exactly that: the guy that will go into crevasse, that will all start with contradiction, where people stop with contradiction. I think the philosopher starts with contradiction. Doesn't mean that he doesn't like physics. He needs to be knowledgeable in physics, in law. Sometimes I'm criticizing some, especially in France, of my colleagues, philosophers, anthropologists, they are supposed to work on science, but they don't know the current science. So I think you need to know what is actually happening to start with the contradiction.
Right. No, but I agree. Philosophy should be dangerous. You know, there was a school that said that, you know, you have to have rigorous mathematical definitions of what you're doing in philosophy. And a colleague of mine who died some years ago, Giancarlo Rota, he said, in mathematics, you start with a definition, but in philosophy, you end with a definition, and maybe you never get there.
Yes, exactly.
With a rigor edition.
You know, it's interesting what your metaphor with the crevasse, the mountains, the place we have to go, like that's dangerous, don't go there, etc. It's a bit like what says Nietzsche, the German philosopher, because he said, look, if you're not ready to live and to try to climb mountains where there is just thin air, not a lot of oxygen, but you get a bigger perspective, but in the same time you can have vertigo and all that. If you're not ready to do that, don't read me.
Yeah, well, that's where the excitement is, actually. Yeah. If you stay in safe physics and safe mathematics, it's a bore.
Yeah, you know? Sure. But in the same time, it's dangerous if you go too far.
Right. You can end up in an insane asylum. Yeah. In the worst case.
So to come back again to our question, I'd like to know if you think that coming to Cantor, that we have talked already extensively about Cantor's different infinities. Do you think we can find those...
And Turing's oracles, which is another infinite hierarchy of...
Yeah. Yeah. So do you think we can find those different infinities, like bigger and bigger or smaller and smaller infinities, in the concrete world, in the empirical world? It's like what we find in pure mathematics. Can we find it in the biological world, for instance, or in the even the material world, like all around us? Do you think we can find it around us, or it is just mathematical speculations, or what does it say to our world?
It's conceivable that the physical world could contain oracles for the halting problem. For example, if you can divide time, you arbitrarily small, you could have one step of a computation done in 1 second, the second step in half a second, the third step in a quarter of a second, and in 2 seconds you could do an infinite number of steps, you know, and that would give you an oracle for the halting problem. I mean, it's conceivable, one can define it mathematically, but is this world that way?